do this question one step at a time. Find dy by dt. Y is given as t squared minus t. So dy by dt is 2t minus 1. Derivative of t squared minus t. Next one, find dx by dt. That is the derivative of x. That's 3t squared plus 0. So 0 don't need to be written. We have only 3t squared. Next one is find dy by dx. dy by dx, the definition is for parametric equation dy by dt divided by dx by dt. We have already found dy by dt, which is 2t minus 1 divided by 3t squared. So that is your first three answers. Okay. Now, before we move forward to the second derivative, I'm going to find the points where the tangent is horizontal. Tangent is horizontal if dy by dt is 0. Therefore, if dy by dt is 0, basically 2t minus 1 equal to 0. T is equal to what? Half. We need to give the points where tangent is horizontal. So we will need to find x at half. So half cube plus 1, and y at half square minus half. That's 1 by 8 plus 1, basically 9 by 8. And y would be 1 by 4 minus half, basically negative 1 by 4. So the point where tangent is horizontal is 9 by 8, negative 1 by 4. Next is point where tangent is vertical. Tangent is vertical when dx by dt is 0, because we want dy by dx to be infinity, and so for denominator is 0. Dx by dt is 3t square, 0, that means t is 0. Therefore, point where the tangent is vertical is x is equal to 0 cube plus 1, 1. Y equal to 0 minus 0 is 0. So point where tangent is vertical is 1, 0. That is your answer to the second part. So let's look at the second part. We need to find second derivative. The formula for the second derivative when the equation is parametric is the derivative of dy by dx, but with respect to t, divided by derivative of x with respect to t. So basically, quickly find derivative of dy by dx with respect to t. How are we going to find it? We are going to differentiate 2t minus 1 by 3t square. Quotient rule, 3t square whole square. The derivative of 2t minus 1 is 2 times 3t square minus 2t minus 1 time derivative of 3t square is 60. That's 6t square minus 12t square plus 60 divided by 94. So negative 6t square plus 60 divided by 94. You can factor out negative 60 from here. It will be left t minus 1 divided by 94. One factor of t cancels and 3 cancels. Negative 2 t minus 1 divided by 3t cube. Okay, we have this which we calculated. This is the numerator of the second derivative. Let's put it here. Negative 2 times t minus 1 by 3t cube divided by dx by dt we have already calculated, which is 3t square. Therefore, this is negative 2 times t minus 1 by 3 times 3, 9 t the power 5. This is your second derivative of y with respect to x square. Now the question is, for which values of t the graph is concave up and concave down. Okay. For that, we need to figure out when the second derivative is positive, because concave upwards means second derivative is positive. Okay. For that, we need to find critical points. Critical points comes from second derivative equal to 0 or second derivative does not exist. Now, this is a second derivative. It becomes 0 if the numerator is 0. Therefore, t is equal to 1. That critical point comes from the second derivative 0. And second derivative does not exist if the denominator becomes 0 of the second derivative, which is t. So, t equal to 0. So, you draw a number line, you point two of your critical points, and you find your test points. So let's say negative 1, half, and 2. You find at these critical points the value of the second derivative. Okay, so put this critical point in the second derivative. I don't want you to figure out the whole value. You just need to tell me the sign here. So when I put negative 1 in the critical point, it's gonna be, when I put negative 1 in the second derivative in this function, answer is gonna be negative. When I put half in there, negative 2 times half minus 1 is negative, and denominator is positive. Negative, negative, positive. When I put 2 in there, that's gonna be a negative number. Therefore, so for the second derivative, sign chart is at negative 1, second derivative is negative, at half it is positive, and at 2 it is negative. Therefore, graph is concave upwards from 0 to 1. Function is concave up when t is between 0 to 1. That is your answer for the concave.